Q4, last unit in the Pythagorean Theorem, and we are going to talk about special right triangles. There are two forms of special right triangles. There are 30, 60, 90 triangles and 45, 45, 90 triangles. These triangles are seen throughout geometry, throughout calculus, throughout college algebra. So get trig, definitely trig. And so get used to it, especially if you're going to go on and do bigger and better things in math. So I'm going to explain where things are going to come from, but after that, you can take it or leave it or whatever. All right, so a 30, 60, 90 triangle. A 30, 60, 90 triangle comes from an equilateral triangle. All sides are the same. If all sides are the same, then all angles are the same, and to add up to be 180, 180 divided by 3 is 60, so all angles are 60 degrees. Now, if we have an equilateral triangle where the sides are 2, and I split it in half, then this 60-degree angle is going to turn into 30 degrees and 30 degrees. And then this length right here, it was 2, so now it's 1. So that's what this is showing. And if this is 2 and this is 1, then if I use the Pythagorean Theorem, and I know the hypotenuse, so I take the square root of the hypotenuse squared minus the leg squared, I would get 4 minus 1, and it would be the square root of 3. So this side right here would be square root of 3, and that's what this is showing right here. So if you have a 30, 60, 90 triangle, and you know one side, you're going to be able to find the other two sides if you are able to remember this ratio or proportion. So, but other ways of getting the answers, I kind of gave you some shortcuts. There are other ways to be able to find these answers, but because we haven't spent a lot of time with simplifying square roots, I think that this is going to be the easier way for me to tell you what's going on. So 30, 60, 90 shortcuts. If you know the short leg to 30, 60, 90 triangle, and you want the hypotenuse, you're going to multiply the short leg by 2. Vice versa. If you know the hypotenuse, and you want the short leg, you're going to divide by 2, because it's just doing the opposite of whatever it is. If you know the short leg, and you want the long leg, all you're going to do is put square root of 3 with it, or multiply by square root of 3. So if you want the long leg, if you have the long leg and you want the short leg, then you're going to divide by 3. By square root of 3, sorry. And then if you have the long leg and you want the hypotenuse, this is when it kind of gets a little bit more complicated. You're going to multiply by 2 and divide by square root of 3. If you have the hypotenuse and you want the long leg, you're going to divide by 2 and basically multiply by square root of 3. So let's talk about the easier ones first. Let's do short leg and hypotenuse. Now let me reiterate. This is your hypotenuse, and the short leg is always half as big as the hypotenuse, or the leg that is with 60 degrees is always half as big as the hypotenuse. So let's talk about hypotenuse and short legs. Okay, so on this, you're given the hypotenuse and the short leg. Remember, if I expand this to be an equilateral triangle, then all of this would have been 16. So this right here, x is going to be 8. So on this one, if I know the short and I'm wanting the hypotenuse, then I just double it and I get 14. Those are the easiest ones, okay? Now, let me erase some of this. Okay, now, if I have the hypotenuse and I want the long leg, so we're looking for y, we just a second, hypotenuse and another hypotenuse, and I want the long leg. So we're going to take the hypotenuse, put square root of 3, and we're going to put it over 2. The 16 and the 2 reduce. So this would be 8 square root of 3. Not too bad as long as you have these rules right here. I had the hypotenuse and I was wanting the long leg. So I divided by 2 and I put square root of 3 on top. Okay. Now, whenever you have the short leg and I want the long leg, I'm just going to put square root of 3 with it. And then when you have the long leg, let's see. So let's find y first. When you have the long leg and you're trying to find the short leg, you're going to divide by square root of 3. But this is why I'm not going to go too in depth with everything else, because this is when it gets a little bit more complicated for you since you don't have a really good background on this. You cannot leave a square root on bottom. So to be able to get the square root off the bottom, whatever the square root is, you're going to multiply both top and bottom by another square root of whatever it is. So 8 square root of 3, and then you'd multiply square root of 3 times square root of 3, which is square root of 9. But lo and behold, what's the square root of 9? Just 3, okay? So there you go on that. Then, if you have the long leg and you're looking for the hypotenuse, you're going to multiply by 2 and put square root of 3 on top, because the hypotenuse is twice as big as the short one. So this would be 16 over square root of 3. We cannot leave a square root of 3 on bottom. So whatever it is, we multiply by square root of 3 over square root of 3, which is 16 square root of 3 over 3. So that's what the hypotenuse would be. It's kind of yucky, kind of gross, I know. I'll help you with it. Okay, so let's do these easier ones first. When you have the short leg, that's always going to be the easier one, because you're either going to double it or you're going to put square root of 3 with it. So on this one, square root of 30 degrees we're looking for. So it would be 9 square root of 3. And on this one, 3 is half as big as the hypotenuse. So that's going to be 6. That's when you have the short leg. Now, this is your long leg, and we're looking for the hypotenuse. So we're looking for Q. So we take 6 square root of 3, we multiply it by 2, and we divide by square root of 3. Now this one's pretty handy, because if you have a square root of 3 on top and a square root of 3 on bottom, those will cancel out. And so you're just left with 6 times 2, which is going to be 12. Okay. We're given the hypotenuse, and we want the short leg. So we're wanting J. The hypotenuse is twice as big as the short leg, so we're going to divide by 2. 2's cancel out, so this is just going to be square root of 3. And for some reason, let me squish this up a little bit. I apologize. This problem is the same as this problem. No, it's not. No, it's not. Never mind. I was doing it the other day and thought it was, but it's not. So let's push that back up. Okay. So now we're given the hypotenuse. We're looking for the long leg. So 6 square root of 3. If you have the hypotenuse and you're looking for the long leg, we multiply by square root of 3 on top, even though there's already a square root of 3, and we divide by 2. Square root of 3 times the square root of 3 is square root of 9 over 2. Square root of 9 is 3 over 2. 6 times 3 is 18 over 2. So your long leg is 9. We're given the long, and we want the short. So we're going to divide by square root of 3. You cannot have a square root of 3 left on bottom, so whatever it is, you do it again. So this would be 6 square root of 3. Square root of 3 times square root of 3 is square root of 9, and square root of 9 is 3. And these reduce to 2 square root of 3 because that would have been a 1 on bottom. You want the hypotenuse and you want the short. You want the hypotenuse and you have the short. So you have the short, you double it, you get 14 square root of 3. You have the short, you want the long, so you put square root of 3 with it. You want the hypotenuse, and you have the long, so you divide by 2. You multiply by 2. I am messing up a lot today. And divide by square root of 3. Now watch this. Let's do some math. This 2 and the 10, they are both on top, so that would be 20. And because the square root of 6 and the square root of 3 are both inside square roots, the 6 is on top of the 3. The 3 goes into 6 2 times. So I have square root of 2 left on top and nothing left on bottom besides a 1. Okay, I'm going to pause there because I'm running out of my 15 minutes for this video and go on to the next one.